on exercise 2.2b reads that using diagrams, that is circle, we have to find the HCF of 120 and 126. HCF simply means the highest common factor of 120 and 126. Now, in order for us to get the HCF using circles, we shall first of all express 120 as a product of its prime factors as well as 126. Thereafter, we put them in a circle where in two circles where we have that of 120 and 160 with an intersection where we have the factors that are common to both 120 and 126. Now, how do we determine the HCF at that point? The product of all the numbers in that point of intersection gives you the HCF of 120 and 126. So let's first of all get the express 120 and 126 as a product of its prime numbers. So we have 120 divided repeatedly by prime numbers. We'll start with 2, and 2 can go into 120 because the last digit of 120 is divisible by 2. So 2 into 1 it cannot, 2 into 12 is 6, into 0 is 0. We divide again by 2 for same reason. 2 into 6 is 3, 2 into 0 is 0. We divide again. 2 into 30 is 15. 2 can no longer divide 15 because the rules for divisibility states that the last digit must be a multiple of 2, of which 5 is not a multiple of 2. So we then test if it is divisible by 3, which is the next prime number, and 15 is divisible by 3. Reason being that the rules for divisibility by 3 states that the sum of the digits in that number must be a number that is divisible by 3 or a multiple of 3. So when you add 1 and 5 together, it gives you 6, and 6 is said to be divisible by 3. This rule is only applicable to numbers that are divisible by 3. So you are not to use it when you are looking for numbers divisible by 4 or by 2. So 3 can divide 15 5 times, and 5 being a prime number, 5 can divide itself 1. So therefore 120 being expressed as a product of its prime factors is said to be equal to 2 times 2 times 2 times 3 times 5. We then do same for 126. 126, we'll start using the least prime number, which is 2, and 126 is divisible by 2 because 6 being the last digit is said to be a multiple of 2. So 2 into 1 it cannot, 2 into 12 is 6, 2 into 6 is 3. 63 is not divisible by 2 because the last digit being 3 is not a multiple of 2. So we then test for the next prime number, which is 3. Is 63 divisible by 3? Yes. Reason being that when you sum up the digit in 63, it gives you a digit that is divisible by 3 or a multiple of 3. 6 plus 3 is 9. So it therefore means that 63 is divisible by 3. So 3 into 6 is 2. 3 into 3 is 1. Is 21 divisible by 3? Yes, for same reasons. 3 into 21 is 7. 7 being a prime factor is only divisible by itself and 1. So 7 into itself is 1. So 126 being expressed as a product of its prime factor is said to be 2 times 3 times 3 times 7. So let's say the common factors. 2 is common. 3 is also common. So these are going to be in the intersection. Then we then draw the circle. This is for 120 and this is for 126. Those factors you can find in both are said to be 2 and 3. Then those you find only on 120 is said to be 2 2, 5, and in 126 we have 3 and 7. So if you multiply out all this, you see arrive at 120. If you multiply all this, you see arrive at 126. So the highest common factor, which is the HCF of 120 and 126, is said to be the product of those in the overlapped region, which is 2 times 3, and 2 times 3 is said to be 6. It therefore means that 6 is the highest common factor of 120 and 126. Kindly like my videos as you watch. While I recommend that you subscribe to my channel on YouTube and follow me on Facebook. Also turn on the notification bell so as to be notified whenever a new video is being uploaded. I also recommend that you use the comment section to interact with me on areas that are still difficult for you to understand, while you share the link with your friends and families so that they can also benefit from our daily classes. We shall now take the next question on exercise 2.2.